welcome Algebra 2A students. We're going over a quiz, Systems of Equations, Elimination version 1. So our first set of problems here, 1 through 4, we're going to add each pair of expressions and simplify completely. So you could, if you wanted to, you could write this out horizontally, but what we're going to see here typically with the systems is that the equations will be kind of stacked vertically. So I'm just going to take this second expression and I'm going to write it underneath. I'm going to line up the like terms, so line up the x's with the x's and the y's with the y's. And if I add these expressions, well, let's see, negative 2x plus 2x would be 0x, and then positive 8y, and that is 1y, would be positive 9y. Now, I would probably accept that if this was a quiz or a test as a correct answer, but technically, if you want to make this as simple as possible, you don't need to say 0x. You can just say 9y. That's it. So x, basically x was eliminated or x canceled, the negative 2x and the positive 2x canceled. Okay. Similarly, for number 2, I get a little sneaky here. First expression is y plus 3x. Second expression is x minus y. So maybe we want to say this is a x plus negative y or x plus negative 1y. And then now that it's addition, we could switch it around. So we could say negative 1y here plus x, and that'd be plus 1x. So if we add these expressions together, and this would also be 1y here, 1y and negative 1y would be 0y, and positive 3x and positive 1x would be positive 4x. And again, we don't need to say 0y. In this case, we can just say it's positive 4x. That would be your simplified answers, completely simplified. Number 3, here might be good to remember that technically I would count that as a negative 3y in the second expression. So 2x and a negative 3y, adding those together. In this case, negative 3x plus 2x would be negative 1x, and positive 2y plus negative 3y would be negative 1y. You could write it this way, or if you wanted to, you could just say negative x minus y. Again, I would accept either way, but they're neither one canceled. Number 1, x canceled. Number 2, y canceled. Number 3, we still have x and y, neither one canceled, but that's okay. And then number 4, last one for this section, if I line this up here, negative 9x plus 5y, again, I might want to say the first expression is plus negative 5y. If I add these expressions together, in this case, 9x and negative 9x added together is 0x, no more x's, and negative 5y plus positive 5y is 0y. And I do have the plus between them, technically. But in this case, no x's and no y's, that's just 0. There's literally nothing there. So I'm going to make a quick note if you want to notice 1, 2, and 4, we had the variables cancel. I'm just going to make a quick note about that. So here you go. Here's that note written out. So when did the variables cancel? The variables canceled when they had opposite coefficients. So a negative 2x and a positive 2x. That's what I mean by opposite coefficients. Negative 2 and positive 2 added together is 0. Number 2, we had positive 1 and negative 1 for y. Those were the coefficients of y. Yeah, those together it's 0. They cancel. Number 3, neither variable canceled because we don't have opposite coefficients. Negative 3 and positive 2, in both cases, both variables had coefficients of negative 3 and positive 2. That doesn't cancel. We had x and y still hanging around in the answer. But number 4, they both had opposite coefficients, positive 9x and negative 9x. Those are canceling. Negative 5y and positive 5y, those are canceling. So that's something to keep in mind when we do this thing called elimination. That's typically what we go for, is we want the variables to cancel. We want one of the variables to cancel. So we want opposite coefficients, like a negative 2 and a positive 2. All right, in the next section, I think I'm just going to do number 5 for time here, but our instructions say to multiply each equation by the indicated number, simplify completely. So we're supposed to, here's our equation, x plus 3y equals negative 10. We're supposed to multiply that equation by 5. So the way a lot of people will do the work, they'll have the equation and they'll put the entire equation in parentheses and then put whatever they're multiplying by, in this case a 5, put that outside parentheses. So this is pretty much the distributive property. Technically, I don't know if it's the distributive property, but everything's going to get multiplied by 5. So we'll do 5 times x, that's going to be 5x. We'll do 5 times positive 3y, that's positive 15y. And we're going to do 5 times a negative 10 also. That's coming after the equal sign, so that's going to equal negative 50. Simplify completely. There's nothing to simplify at this point. It's 5x plus 15y. That doesn't combine. They're not like terms. And we don't have to do anything else with that. That's it. So that'll come up later in a future problem. We'll refer back to this problem here to say, hey, remember how we multiplied the equation by 5? Yeah, that'll come up in a little bit here. Otherwise, number 7, checking. Kevin was solving the system of equations that follows. We got those equations, and Kevin got x equals 3. Is he correct? So this is not a system that I expect that you're going to solve in our class because of the x squared term. But if we're just checking here, we can say, all right, well, if Kevin got x equals 3. If you remember the process from solving systems, you solve for the first variable, and then you use that variable value to solve for the second variable. So I could choose either equation here. I'm actually going to choose the first equation. So the first equation might look a little scary because of that x squared term, but it is the x value being squared. So it would be the 3 that we're squaring, not to leave a variable squared. We have a number to square. So this is an equation now that I can solve for y. Let me scoot down here a little bit. I can simplify 3 squared, that's 9. So this is 9 plus y equals 11. And if I subtract 9 on both sides, I'll get my answer for y, that y is going to equal 2. Now, does this mean that Kevin's right? Does it mean that Kevin's wrong? Well, I need to now check to say, does the x value of 3 and the y value of 2, does that work in the second equation? So let me check that out. So checking the second equation, since I used the first equation to get the y value, I'm going to check the second equation. 5x plus 3y equals negative 21. Well, we have an x value of 3. We figured out y value of 2 based on the first equation. Does this work? Is this true? Well, let's see. This is 15. 5 times 3, 3 times 2 is 6. And, ooh, not quite. This is 21. This is a positive 21. That is not equal to a negative 21. So that's a false equation. So is Kevin correct? No, he is not. And we've shown our work here. You might also say the first equation says y equals 2, but that fails. X equals 3 and y equals 2 fails in the second equation. All right, so for the next section, I'm going to do a couple of these problems. Start with number 8 here, but just a reminder, the elimination method is when you add equations, and we saw from the warm-up, or not the warm-up, the first section, 1 through 4, when you have variables with opposite coefficients, those will cancel if you add them. So number 8, if we add these equations, right away I can say, well, you got negative 1y here, and you got positive 1y. That, if I add those, that would eliminate. Negative 1y and positive 1y added together is 0y, which is 0, so no more y's. Y goes away. But I have to add the entire equation. So when I add 4x and a negative 1x, when I add those, that'd be a 3x. Y is eliminated, 0y, which you don't need to say. And the equal sign, 29 plus negative 8, would be a positive 21. So again, just to kind of look at this and realize what we've accomplished, we went from a system of 2 equations with 2 variables, and now I have one equation, 3x equals 21, and x is the only variable. So I can solve this for x. Divide by 3, I'll get x equals 7. So that was pretty quick to come up with the x value. Now I need to solve for the y value. So I can choose the first equation or the second equation, go back to the originals. I'm going to choose the second equation because me personally, the minus y in the first equation, I don't like that. So I'm going to use the first equation. sorry, I'm going to use the second equation is what I meant. Negative x plus y equals -8. If I put in that 7 for x, don't forget we have the negative. And don't forget if x had a negative value, then the second equation would be negative from the equation and the negative value for x. You can also squeeze in that 1 there if you want. You can say -1 times x if you really wanted to. But that's 7. That's -7 plus y equals -8. So I can add 7 to cancel that and add 7 to balance. And I get y equals -1. So I've got an x value, I've got a y value. It seems like I've solved the system. The only thing to do is to check this. And since I used the second equation to get the y value, I'm going to check the first equation with both of these numbers. Okay, so checking the first equation, 4x minus y equals 29, using both values. X is 7, we believe, 4 times 7. And remember, we're subtracting the y value. So it's not -1, it's -1. Again, if you want to squeeze in a 1 there, you can say -1 times -1. But this would be 28. If it's a -1 times a -1, that comes out to a +1. And is that 29? You bet it is. 29 equals 29. That works out. That's true. So x equals 7, y equals -1, or we might write it in coordinate form or as an ordered pair. 7, -1. There you go. We'll do, I'll kind of get started here with 9 and 10, but I'm not going to do the whole things just for time. Number 9, if you notice, we have 1x and -1x. So those are opposite coefficients. Those will cancel if we add these equations together. Keep in mind this would be a -5y in the second equation. So here we're going to get the cancellation, the elimination. 1x plus -1x is 0x. Don't have to write that. That's a +1y plus a -5y would be a -4y. And then 16 plus -42, or -48, excuse me, would be -32. You can solve this for y. Take that y value. Pick which equation you like. I like that first equation, x plus y. Take your y value, put it into the first or the second equation, and get your x value, and then you can check. So finish that one up. Number 10, we've got opposite coefficients in the x variable again. +4x and -4x. If we add those together, that's 0x. We'd have a -2y here and a -3y. Those added together is a -5y. And then 10 plus 45 is 55. So again, you can finish solving that for y. Take that y value, put it in the first equation or the second, solve for your x value, and then check the other equation. Okay, and it should work out if you're doing everything correctly. Number 11, if you notice, is a little different because right now there are no opposite coefficients in number 11. The +1x and the -5x, those are not opposites. +3y and a -1y are not opposites. So if you added these together, you would get -4x plus 2y equals whatever that is, 96 over there, I think. And that's not good because we still have both variables. Both variables are still in the equation. Not like number 8, number 9, number 10, when we had those opposite coefficients and we added, one of the variables was eliminated. One of the variables went away. But if you remember, let me erase this here. If you remember on the previous page, what number was it? Number 5, we had, that equation looks familiar. X plus 3y equals -10. That's our first equation. X plus 3y equals -10. What did we do in number 5? We were told to do this, but we multiplied the equation by 5. Everything in the equation, x, 3y, and -10, all got multiplied by 5. That gave us 5x plus 15y equals -50. 5x, +5x. That's what happened to the first equation. Well, if I had a +5x in the first equation, that would cancel with the -5x in the second equation. So that's what we can do here. We can manipulate one or both equations. I'm going to multiply this by 5 because that's going to give me a +5x that will then cancel with the -5x when I add those together. Remember, I have to multiply everything. So 5 times 1x is 5x, 5 times the 3y is a +15y, and then 5 times -10 is -50. The second equation, I'm just going to rewrite it. I don't have to change anything in the second equation. But we've got the 5x now and the negative 5x. Those are going to cancel. I'll write this as plus negative 1y equals 106. So now if I add those equations together, now I'm going to get this cancellation. 5x and negative 5x is going to cancel. No more x's. I'd have 14y. Let's rewrite that. 14y. And then that's going to equal, I think that's 56. So you can finish solving for y. You can take that y value, go back to the original first equation. If you're going to use the first equation, use the original. Don't use the modified one, because what if we made a mistake? What if 5x plus 15y equals negative 50 was wrong? Go back to the original equations to solve for your x value after you get your y value. All right, and then to finish this up, number 12, a little bit of a story problem, not so much a story, but we got words. It says the sum of two numbers is 164. The difference of the same two numbers is 26. What are the two numbers? Now, I didn't give you a hint here, but you might just call the numbers x and y to start. You know, it's not pencils and calculators where you might use p and c, or it's not hours and cost or whatever. It's just two numbers. So the sum being 164, we could write that out. Sum is addition. So the sum of x and y is 164. I could say x plus y equals 164. The difference is subtraction. So we could say for the difference equation, we could say that x minus y is equal to 26. So I've just created a system of equations. I notice that I've got positive 1y and negative 1y. So those will cancel if I add them together. This is set up for elimination. If I add these together, y will go away. X plus x, that's 1x plus 1x, that's 2x. Positive 1y, negative 1y is 0y, which is 0, which I don't need to write. And 164 and 126, I believe that is 190, if I'm doing my mental math correctly. Okay, this one I'll go ahead and finish up, but I can solve this for x. If I divide by 2, that would be x would be 95. I'm going to choose that first equation. I'm going to choose the sum equation to solve for the y value. So x plus y equals 164. This becomes, with the x value 95, that's 95 plus y equals 164. And I can solve that for y now. I can subtract the 95, and oh boy, I don't know if I can do that mental math. Let's grab the calculator here. What is 164 minus 95? I feel like I should be able to do that. 69. Okay, so y equals 69, and then of course let's check the second equation. Let's check the difference equation. It's supposed to be the difference. If we subtract, we're supposed to get 26. So is 95 for x minus 26 for y. Whoops, not 26 for y. 69 for y. Is that equal to 69? Or 26. Not speaking correctly, but I'll write it correctly. Is that true? Well, again, I can grab the calculator here, and let's see. So 95 subtract 69, we get 26. All right, that looks good. That worked out. So yeah, what are the two numbers? 95 and 69. Those are our numbers there. So hope that video helped you. We'll see you in the next one.